Welcome back. This is our level the way we set it up in the last video with the night sky and the sort of tile floor. And now that we've got the level set up the way we want, we can add our gameplay elements. The one we're going to start with is the battery. The battery is actually a result of using 3 different classes. The first class is going to be a really generic pickup class. It's not going to have much functionality built in, just things like a Boolean variable to say if the pickup is active or not, a sphere component and a static mesh component, so you'll be able to tell where the pickup is in the world, and a function to specify the pickup's behavior when it's collected. So we'll start with this class and then build on it later in future videos to make the more specific battery types. So let's get started with that generic pickup class. One of the easiest ways to add code to your project is with the wizard in the editor. If you go to File, Add Code to Project, a window will pop up asking what class you want to base your new class on. We've got, characters, pawns, but the one we really want is actor, which is just the base class for any object that can be placed or spawned in the level. And like I said, our pickup is really generic, so this is a great starting point. Go ahead and select that, and then click Next. And we can name our new actor. We'll go ahead and name it Pickup. As you can see, the path has already been set for us, which is one of the reasons using the wizard is great. It's in our project folder and the source folder inside of that, and our module folder inside of the source folder. So these files will be ready to go as soon as we create the class. We'll get a new header file and a new source file. So go ahead and create the class now. It's going to generate the project and then ask if you'd like to edit the code. Go ahead and say yes. And Visual Studio will prompt you to reload, which will also ask you to stop debugging. So go ahead and say yes, reload, and yes to the debugging question. So it will go ahead and load your header file. Now in your header file, this is where you will do things like declare any variables, functions, or components that your class will contain. In the source file, the .cpp file, that's where you'll actually set the values for variables or set the behavior of your functions. And as you can tell, this actually isn't an empty file. When you start, the wizard has already added some code here for you. So our pickup is based on actor. So we've got the include of actor, so we can access any of the functions or variables from the actor class. We also include a specific generated header, which you will never have to go edit. It's just in there for the Unreal Build tool to be able to work with. So those are just the includes that are already added for you when you use the wizard. Next, you've got the uClass macro. This uClass macro lets you set various properties for the class, which also makes the engine aware of the class for things like garbage collection and access in the editor. So if you wanted to make a class that normally wouldn't be able to be made into a blueprintable, this is where you could specify things like that. We're just going to leave it as it is for now, but this uClass macro is really going to be useful as you start setting a lot of specific things about your new classes. Next, we've got the class declaration. In the class declaration, we've got that it's our class is a pickup, and it extends from a actor. Actually, let me make this just a little bit bigger so you can hopefully see what's going on. Inside the class declaration, we've got this generated uClass body macro. Again, this is just something that's specific to Unreal. You won't ever have to worry about it. Just always make sure that it's there and at the top of your class declaration. So now we can start adding our specific behavior. We will first add our Boolean. This Boolean value will tell you whether or not the pickup is active. Basically, will you be able to collect it or not? Now, just like the uClass macro, we have a uProperty macro, which you can put it on top of any variable that or most variables that you specify in your classes. Again, like the uClass macro, uProperty can have different keywords entered into it. So, for instance, if we'd like to be able to set whether or not the pickup is active inside the editor, we can make this edit anywhere. And also, if we want to be able to change it in a blueprint of our pickup, which we will down the line, we can make it blueprint read write. Now, one thing that's very important when you're going to have variables that are editable or readable is you need to set a category for them. This is so that the editor knows where to put them in the details panel. So we've got all that set up, and now the engine will be aware of our Boolean variable, will let us edit it in any details panel, and will also let us read or write it in a blueprint based on this class. We will also go ahead and add a comment so that when we come back, we know why we added this Boolean. So it's true when the pickup is able to be picked up, and it's false if something deactivates the pickup. Now we'll go ahead and add our components. Now we're going to have two components. The first is a sphere component. So basically, it's going to be the root component. Everything will be attached to this invisible sphere so that you can always have this sphere to overlap or to interact with. Just like a variable, you can put a uProperty macro on a component. The difference is you don't use edit or read-write specifiers here. You can use visible, so visible defaults only, or blueprint read only. And again, because you want these to be visible in the editor, you need to specify a category. We'll just use the same pickup category. The reason that you use visible or read only and not edit or read-write type of variable or specifiers on components is that once you're in the editor, you're never going to be able to actually remove any components that you've set up in code. So using the visible read or write keywords, the visible or read keywords makes the components available for viewing, and then any variables on those components will obey their own rules. So it's just a little quirk to know when you're working with components, you're only going to want visible or read only specifiers, not edit or read write specifiers. Again, we'll go ahead and add a little comment here. So this is our simple collision primitive to use as our root component. And we're going to add a static mesh component, which is going to have the same properties. Again, it's visible defaults only, blueprint read only, and in the pickup category. And this pickup mesh is just going to be so we can set a static mesh so we can actually see our pickup in the level. Finally, we're going to have a function. This function is going to be called onPickedUp. And basically, it's just going to set the behavior for when the player collects the pickup. So just like we used the uClass macro and the uProperty macro before, we have a uFunction macro that we can set on our new function. We are going to make this function a blueprint native event. This means that you'll be able to override the function in a blueprint, which we'll do later on in the tutorial series. The thing about blueprint native events is if you don't have a blueprint with a specialized override for this function, you will just call the function the way you set it up in code instead. So it's basically got a backup functionality that you can set in code. And we'll go ahead and comment that as well. So this is our function to call when the pickup is collected. So just to go over again, we've got our Boolean for activation, our sphere and mesh components, and our onPickedUp function. And that is everything that we've needed to add to our header file. We'll go ahead and save this and switch to our source file. So again, our source file is over here in the Solution Explorer under source tutorial code. We've got pickup.cpp. There's some more code that has been automatically added here as well. As you can see, we've included the tutorial code, the module header file, and our pickups header file. This is very important so that any variables or functions we set up over here in the header file, we will have access to over here in the source file. this is our class constructor. So basically anything you want to have happen or be set when the a copy of the class is created in the world, an instance, then you would set that here in the constructor. So for our constructor, we're going to say that basically as soon as the pickup is created, it is active, so that'd be true. And we will go ahead and start creating our components. So I said the sphere component was our root component. So that will be the one we create first. So we've got a base collision component, and we'll use this create default subobject template to create our new component. Then we will set the sphere component as the root component. To do that, it's pretty straightforward, just root component equals base collision component, which is the component we just created. Next, we're going to create the static mesh component and attach it. So the static mesh component is going to be literally the way we can see the pickup in our level. So again, we're going to use the helper to create the component, this create default subobject helper. We're actually also going to turn physics on for the static mesh so that these batteries fall down to the floor as they're created up above the player. So to do that, it's pickup mesh, and we'll set simulate physics to true. And again, this is just so that the pickups will collide, so they'll have gravity act on them, basically, so they behave like realistic physics objects. And then finally, we need to attach the static mesh component to the root component, so that wherever the the root component moves, the static mesh component will move too. And attach to root component. Now we've had our entire class constructor set up. So again, every time a pickup is created in the world, the pickup will be set to valid. There will be a root component that's a sphere component, and there will be a static mesh that has physics on that's attached to that sphere component. So that's every single time a pickup is created in the world. The other thing is we have that onPickedUp function from before. Normally you declare a function or define a function with like so. So a pickup onPickedUp, which was the name of our function. The thing is, this is a Blueprint native event, and I told you that the Blueprint native events go first to the blueprints to see if there's a function there to call, but if they don't, then they come back to code. So this is sort of our backup function, and as a result, we have to change the name. So the way you actually define a function when it's a Blueprint native event is it would be the function name, so onPickedUp, and then underscore implementation. And we actually don't have any default behavior for a pickup. You know, some pickups you might give you health when you pick them up. Some pickups might decrease your health. So we don't actually have any default behavior here. So this is actually going to be an empty function. It's just a sort of building block for other functions for other classes that are pickup types to build upon. So there is no default behavior for a pickup actor when it's picked up. So now we will compile again and load the project in the editor so we can make our battery class that extends from the pickup class in the next video. I'm going to go ahead and right-click, debug, and start new instance, and this is going to rebuild. The reason we have to rebuild this way and you can't just compile from within the editor is every time you add a new class, new function, or new variable, you have to, and you use either the uClass. Oh, I have a typo, set simulate physics. This is what, I should have just copy and pasted that one. Again, debug, start new instance, and build. So anytime you use those uClass, uProperty, or uFunction specifiers, you have to be able to re-register those with the editor. So that's why you've basically got to close and reopen the editor. And just like I said, the future compile times, as you make small changes like this, don't take nearly as long, so we're already ready to go. Again, this is our first new class, the baseline pickup class. And if you come back in the next video, I'll start building a battery on top of that. Thanks.